All right, guys, we're going to continue on with the neutralization reactions. So in our last video, we went over what neutralization was. It's when you mix an acid with a base, it produces salt and water. And so this is really a double replacement reaction where it produces the same types of things, okay? So in our example here, remember, we're working on the concept of this. When you have an hydrogen ion and you mix it with a hydroxide ion, it's going to produce water. And so remember, the key component of an acid most of the time is the H in the acid that gives its acidity, and with the base you have the OH, which is what causes it to be a base. And so a neutralization reaction, these two things are going to combine to form your water. And the leftovers in any double replacement type of equation, your sodium and your chlorine are going to combine over here to form sodium chloride. So for any acid-base reaction, this is the basic format that all of them do. So anytime you mix an acid and a base, it's going to produce a salt and a water, okay? And so what happens is the acid and the base, whatever the molecules or ions are, they're just going to switch partners, shall we say. So this can be done in a wide variety of ways, and we can look at another example. If you look at any type of acid or any type of bases, you can figure out what the salt is going to be, okay? So that's what we're going to practice here. So one of the acids that we can look at is H2SO4, which is sulfuric acid, and we can look at mixing that with a base of let's just use sodium hydroxide, so NaOH. So we know that that's going to produce a salt plus water, right? So let's go ahead and put our water over here because we know what that's going to be. It's going to come from the hydrogen here. The hydrogen here and the OH from here, and it's going to form your water. So what's left over, it is sodium, Na, and sulfate, which is SO4. Now, we have to remember what the charges are on these things. And so sulfate has a -2 charge, right? So let's just down here. So sulfate is SO4 and it's -2. All right, and we know that sodium is Na and it's +1. So when we write our salt equation, we need to balance it just like we did in the previous unit. And so there's a +1 here, -1 here, so that means we need 2 sodium molecules at +1 to equal 1 sulfate compound. So we need to write the correct formula. So it's Na2SO4. All right, so that's an example of that. So here's let's do another example here. Let's take the common acid of nitric acid and mix it with a common base of potassium hydroxide. I want to give you guys a couple minutes to see if you can find out what the reactants are from this neutralization reaction. So go ahead and pause the video here, and I want you to see if you can determine what goes here and here. All right, so first thing you should do is go ahead and write your water, because you know that that's going to be it. Yeah, that's one of your products, so there you go. And so that comes from your OH and your H. So what's left over? You have the, we'll just write it down here. You have the potassium, and it's a +1 charge, right? And you have your nitrate, which is NO3, and it is a -1 charge. So the charges are going to balance out. So just like we learned last unit, we go ahead and write the formula. So that's going to be KNO3, which is called potassium nitrate. So your salt in this case is potassium nitrate. So now let's do one in reverse. Let me give you the salt, and let's see if you can figure out the acid and the base. So let's do the reaction in reverse. So this is, let's say, Al2CO3 plus water. Those are our products. So what is the acid and what is the base? I'll pause the video and see if you guys can figure that out. So the very first thing to do is you take and split your water molecules. So you know that your water molecules is going to form an H, and there's going to be something with an OH, right? You know that. And since you have a positive ion here, and the positive ion is going to have to go over here. So it's going to have to be aluminum, right? And over here, since this is a negative ion, it has to match up with the one over here. So this is CO3, right? So once you split everything and put it where it goes, now you just have to balance the equation to make sure that it's right. So aluminum, as we know, is +3, and OH is -1, right? So we do the switch, it goes over here. So it's going to be Al parentheses OH3. That's the correct formula for that. And over here in your acid, your hydrogen is +1, and your COH, your carbonate is, what is carbonate? I can't remember. Oh, it's -2, right? So that's the case. You just switch. That goes over here. That goes over here. So it's H2CO3. Piece of cake. All right, so what I want you guys to do today, I want you to practice with these. I want you to take a look at your list of common acids and bases. And on page 244, I want you to look at the list of common salts. So I want you to, one, come up with your own equations where you combine the acid plus the base and figure out what the salt is. All right, so let's do, each of you should do 3 examples of that. And the second thing, I want you to start off with the salt and water, and I want you to tell me what the acid is, what the base is. So be sure that you write balanced compounds. All right, so for this one, I need you to give me 3 examples too. All right, so you guys work on that today, and I'll make an assignment on Schoology, and you guys can upload that when you're done. And so you can write this on a piece of paper, just make sure it's legible, and you can take a picture and upload it. Okay? Thanks, guys.